H2O11 is the chemical formula of sucrose, a common disaccharide. It's made up of one molecule of glucose and one molecule of fructose, joined together through a dehydration reaction. Sucrose is widely found in sugarcane and sugar beets and is the table sugar we use every day. It appears as white crystal, dissolved easily in water, and has a sweet taste. In addition to being a sweetener in the food industry, sucrose is also important in the fermentation industry, like in brewing and vinegar production, and is often used in chemical experiments.
Gummy beer is the star of today's experiment. Let's talk about what's inside a gummy beer. Gummy beers like these are made with ingredients such as glucose syrup, sugar, and gelatin, along with a mix of artificial and natural flavors. Chemically, one key component, glucose, has the formula carbon-12, hydrogen-22, oxygen-11. Sucrose is formed when glucose and fructose combine through a condensation reaction, which releases water. When glucose reacts with oxygen, it produces carbon dioxide and water, just as shown in the equation on the board. Safety is paramount during this experiment, and several precautions must be taken to ensure a secure environment. Always maintain a safe distance from the experiment area and ensure that there's no flammable materials nearby, such as paper, cloth, or chemicals. While handling hot equipment, it is essential to wear heat-resistant gloves to prevent burning and injuries. After completing the experiment, immediately turn off the Bunsen burner to reduce the risk of accidental fires and ensure that the area remains clear of any potential hazards. Additionally, always have a fire extinguisher nearby to address any emergencies that may arise. By adhering to these precautions, we can promote a safe and successful experimental process. So, it's time to start our experiment. Wear lab coats and goggles before the exam is really important. It is necessary to protect your clothes, your body, and your eyes. Equipments in the picture are all needed for the experiment. We need test tube rack, test tube holder, Bunsen burner, spatula, the most important things, potassium chloride, and also, of course, the gummy beer. First step, squeeze the gummy beer. This step is pretty important. If we don't do this, second step, use a spatula to scoop a spoonful of potassium chloride and pour it into the test tube. Third step, hold the tube with the tube clamp. Fourth step, open the gas valve and light the Bunsen burner with a lighter. Fifth step, heat the test tube over a Bunsen burner while moving it back and forth to ensure even heating. We heated the test tube for about 10 minutes, and the powder still didn't run into liquid, so we looked at the bottle that contained the powder. Unfortunately, we had used the raw material. It should have been potassium chloride, but we mistakenly used potassium chloride. This reminded us of the importance of carefully verifying the experimental materials before conducting an experiment. This is potassium chloride and this is potassium chloride. Well, I think they look exactly the same, but completely in different function. After that, we do the same steps. Because it was too hot, each team member had to hold the test tube clamp for a while. We then continued to heat potassium chloride, and finally after 3 minutes, it became a liquid.
The chemical equation here is shown in the figure. Potassium chlorate decomposes to produce potassium chloride and oxygen. After the material turned into liquid, quickly move to the quarantine.
In the laboratory, safety is extremely important, and the fume hood plays a crucial role in keeping us safe. A fume hood is a large glass enclosure that protects us from harmful gases, vapors, and flames during experiment. It is especially effective when we conduct experiments that involve high temperatures or dangerous chemicals, as it removes harmful substances from the air. For example, in the gummy bear test, some unpleasant gases are released. By using the fume hood properly, we can reduce the risk of accident and ensure that everyone in the lab remains safe.
Then quickly put the gummy bear into the test tube. At the front, we already heated some potassium chlorate to produce oxygen. After we drip it in the gummy bear, which causes a rapid fiery reaction as the sugar, or we can call it maltose, burns intensely with oxygen, producing carbon dioxide and water.
In this experiment, we heated 5 grams of potassium chloride until it decomposed, releasing oxygen gas. Then we dropped a 2-gram gummy bear into the molten chloride, triggering a rapid and intense reaction. The sugar inside the gummy bear burned violently, producing bright orange flames, loud explosive sounds, and thick white smoke. This reaction lasted about 8 seconds, with temperature soaring over 400 degrees. The main product of this dramatic reaction were carbon dioxide, water vapor, and potassium salts, demonstrating how sugar can release massive energy when rapidly oxidized.
Final step. Don't forget to do some cleaning. Remember to wipe the table and wash the test tube.